Hey guys, so today we're going to be talking about how to find the pH of strong acids and strong bases. So we have to first know how to identify these strong acids and strong bases. So I have a table here that lays out all the strong acids and strong bases that you need to know. So if you're given a problem that involves anything to do with strong acids or strong bases, you'll be able to identify it very quickly. So, just to name off a couple, you need to know hydrochloric acid, hydrobromic acid, hydroiodic acid. Chloric acid you may not need to know, but it is a strong acid nonetheless. Perchloric acid, nitric acid, sulfuric acid. A good way to remember a couple of these is that we know that the hydrochloric, hydrobromic, and hydroiodic are all in the halogen family. It's pretty much the whole halogen family other than fluorine. And the reason for that is explained in the previous video. But it's just that fluorine, it really attracts all those outer electrons to the center of its nucleus, so it doesn't necessarily dissociate completely. And that brings up a very important topic. What is a strong acid and what is a strong base? Well, if we were to have a strong acid, and I'm just going to denote that as HA because, the hydrogen and then some other compound that binds with the hydrogen in order to make the acid. Well, if this is considered to be a strong acid, then what basically what basically separates a strong acid from all the other types of acid is that 100% 100% of this strong acid will dissociate into H plus and whatever the other compound is. So 100% of this strong acid will dissociate into the H plus ion and whatever the other compound anion is. Same thing with a strong base. If we have something and an OH, let's say, and maybe instead of A, put B. If we have a B and an OH here, what makes a strong base very unique is that 100% of the strong base will dissociate into the ions B plus and OH minus. All right. So that's obviously a very, very important thing that we need to know, and that will help us when it comes to solving for pH problems regarding strong acids and strong bases. Strong bases basically consist of all group 1 metals with a hydroxide, so lithium, sodium, potassium, rubidium, cesium. And we also have 3 group 2 metals, strontium, calcium, and barium. A way that you can remember the second exception is something called senior Kaba. If you want to use that as a way that you can remember those other strong bases, you can use that to help you out. So knowing that this is the unique characteristic of strong acids and strong bases, if we're given a problem, let's say we're given a problem that says we have 0.250 moles per liter of hydrochloric acid. All right. Well, we know that hydrochloric acid is a strong acid, so let's write that out. We know that hydrochloric acid is a strong acid. And we know that if we were to just draw out a quick reaction, hydrochloric acid will dissociate into our hydrogen ion and a chloride, a Cl minus. We know that because this is a strong acid, 100% of this hydrogen chloride should dissociate into H plus ions and chloride ions. So with that in mind, we should understand that if we're given a certain concentration of hydrochloric acid, we should have the same concentration of hydrogen ions that we had of hydrochloric acid. In other words, if we're given 0.250 moles per liter of hydrochloric acid, then we know that we should also, at the end of the reaction, have 0.250 moles per liter of hydrogen ions because of that 100% dissociation. So if we want to find the pH of a strong acid, we simply take, to find the pH of a strong acid, we simply take the negative log of our H plus concentration, which we know will be the same concentration of our strong acid because of the 100% dissociation. So negative log of 0.250 moles per liter, that's our concentration of H plus ions, And if we were to plug that into our calculator, we should get a pH of roughly 0.602 for our pH. And notice that I have 3 sig figs here because I have 3 sig figs for our molarity. So basically what I'm trying to say here is that the molarity that you have of your strong acid will be the same molarity, the same concentration of H plus ions when you dissociate it. The same concept applies to bases. So let's do a quick example with bases. All right, and let's use sodium hydroxide for our example. Let's say we have 0.750 moles per liter of sodium hydroxide. Okay? Knowing that sodium hydroxide is a strong base because it's a group 1 metal with a hydroxide ion, we should know that if we have a sodium hydroxide, it should dissociate into a sodium ion and a hydroxide ion. With that in mind, we know that if we have 0.750 moles per liter of sodium hydroxide, because of the 100% dissociation of strong acids, and specifically in this case strong base, we should have 0.750 moles per liter of OH minus at the end of the reaction. So, if we want to find the pH, the first thing we have to solve for is pOH, because that's what we're directly given. We're given a hydroxide concentration. So if we find the pOH of our sodium hydroxide, specifically of our hydroxide concentration, that would be the negative log of 0.750. And the negative log of 0.750 is going to be about, so our pOH is going to be about 0.125 roughly. Okay, and if we were to, if we wanted to find our pH, we know that we're given our pH, we're given our pOH. To get our pH, we need to do 14 minus our pOH because we know that the pH scale is from a scale of 0 to 14. So we know that in order to find the pH, that's simply going to be 14 minus our pOH. So if we do 14 minus 0.125, we should get a pH of roughly 13.875. And this makes a lot of sense, and also makes a lot of sense for the previous example when we had a hydrochloric acid and we got a pH of roughly 0.602. And that's because if you have a strong base, your pH is going to be very basic because you're creating an excess of hydroxide ions. So your pH is going to be very basic. If you have a strong acid, your pH is going to be very acidic. It's going to be lower than 7 because you're creating a lot of hydrogen ions, a lot of H plus ions. So the rule of thumb is whatever concentration you're given for your strong base or your strong acid will be the same concentration for either your H plus ions or your hydroxide ions. So you simply have to plug in this concentration into a negative log and you can find the pH. And specifically if it's a strong base, then you have to find the pOH and then convert that to pH by doing 14 minus whatever you got for this. So it's a very straightforward process, very simple, and it's made very simple because of the 100% dissociation principle. Hopefully this video helps on your knowledge about strong acids and strong bases, and I do recommend watching the rest of our acid-base equilibrium series. Thank you for watching, and peace out.